Good morning. This is your stats sensei, Mr. Spensei, and I'm going to break down our most recent quiz. All right, the American Pets Product Association, etc. They give us this Venn diagram. You use the Venn diagram to answer the questions below. What's the probability that a family owns a dog? Well, dog is this circle right here. So the probability of a dog is 0.26 plus the 0.13 equals 0.39. The next thing, what's the probability a family owns neither a cat nor a dog? Well, that means I basically have a box out here. We don't want what's in the circles. We want what's out there. So to do that, first off, let's find out the probability that they own one. Well, I can go 0.26 plus 0.13 plus 0.21. And that gives me the part in the circle. And if I subtract it from 1, I get the part not in the circle, which is what I'm interested in. So in this case, 1 minus parenthesis 0.26 plus 0.13 plus 0.21, close those parentheses. And I find out that this area out here is 0.4. Let's just check to make sure that this is actually correct. So if I did this correctly, all of that should add up to 1 to be a valid probability distribution. So 0.26 plus 0.13 plus 0.21 plus the 0.4, it equals 1 whole, so I probably did it correct. Now it says, given a family owns a cat. Well, remember, it's intersection over given. Well, what were we given? We're given that they have a cat. Well, what's the probability of having a cat? Cat is the sum of these two, so that's 0.34. What's the probability they also own a dog? So we went intersection dog. Well, what was my intersection? 0.13. All right, because that 13% own a dog, but we have to be within the cat circle. All right, we can't go outside of the cat circle. So 0.13 divided by 0.34. So 0.13 divided by 0.34 equals 0.3823. And remember, I like to truncate, which means we just cut it off at 4 decimal places. All right. All right. So a survey of families revealed that 74% of all families eat turkey at holiday meals and 32% eat ham and 20% eat both. Create a Venn diagram for the above situation, being certain to demonstrate how families have neither turkey or ham. So when I say they want that part, they want this value out here. They're looking for the value out in the box. So both means intersection. They tell me 21% eat both, so this is all right. And it's usually best to start with the both if we can. All right. So in this case, 32% of the family eat ham. 74% eat turkey. Let's start with the 74%. So this is turkey. And it needs to be 0.74. Hold on, I've got things popping up on my screen. And so turkey is 0.74 minus the 0.21. When we do that, sorry about the interruption with the screen beeping, 0.74 minus the 0.21 equals 0.53. All right. Now, this is turkey only, not, and this is turkey and ham. And together they make up the 0.74, or that adds up to the turkey. Then over here we have ham. And a ham was 32%. So this is going to be 0.32 minus 0.11, or 0.21, excuse me. So 0.32 minus 0.21, that's 11%. So 11% eat ham and not, but to eat ham, not including the turkey, but then we also have the turkey and ham. Those two together make the 32% who eat the ham. All right. Now that we have these, we can find this value, and this value is going to be 1 minus 0.53 plus 0.21 plus 0.11. So 1 minus parenthesis 0.53 plus 0.21 plus 0.11, because all I did was add up all the things in the circles and whatever, and then subtract it from 1, and whatever is left are those who did not have turkey or ham. So this is 0.15. Let's check this out real quickly. Should be right, but let's check it out, because when we add up all 4 of these values, it better sum to 1. So 0.53 plus 0.21 plus 0.11 plus 0.15. Hey, sums to 1 whole. We look good there. All right, so now they give me the A union B formula. So that means I need to be writing that down. So the probability of A union B equals the probability of A plus the probability of B minus the probability of A and B. All right, so they tell me A is 0.55. They tell me my intersection is 0.42. Oh, I'm sorry, I wrote this wrong. They said A is 0.55. There we go. They tell me my intersection right here is 0.42. And they tell me my union is 0.4. But what they didn't tell me is what B is. So plus B. And remember, there's a minus sign right there. Well, I'm going to combine the 0.55 and the 0.42. So 0.55 minus the 0.42, that's 0.13. So now I have 0.40 equals 0.13 plus B. I'm going to subtract from both sides. Well, this is messed up. So when I subtract from both sides, I end up getting B is 0.27. 0.4 minus 0.13 is 0.27. So let's check that out. So 0.55 plus 0.27 minus 0.42. And we get 0.4, and that's what we're supposed to have. It looks like we did that correctly after all. All right, moving on to the next problem. Suppose 40% of cars are manufactured in the US, 30% in Japan, 10% in Germany, and 20% in other countries. Find the probability that is made in Japan or Germany. All right, so 30% in Japan and 10% in Germany. So 0.30 plus 0.10, because or means add. So we want the probability of Japan, which is 30, plus the probability of Germany, which is 10%. So this equals 0.40. 2 cars in a row from Japan are selected. So we're randomly selecting 2 cars from Japan. So we want the 2 cars. Well, what's the probability of Japan? 0.3. So 0.3 times 0.3 equals 0.09. Check my math real quickly today. 0.3 times 0.3, boom, 0.09. None of the 3 cars came from Germany. All right, so this is tricky. We don't want German, we want not German, and not German, and not German. The probability of German is 10%, so the probability of not German is 0.9. So this is going to be 0.9 times 0.9 times 0.9. So 0.9 to the 3rd power is 0.729. At least one of 3 cars selected is US made. All right. When I do at least, or when I do at least one, that means we're going to have to do a 1 minus, because you could have 0 cars that US made, 1 car, 2 car, 3 car. Well, we want this, so we're going to do 1 minus the probability that none of them are US made. So we have to do 1 minus the opposite. Well, first off, what's US made? US made is 40%, so the opposite of US made is 0.6, and I need 1, 2, 3, because anytime it's at least is the probability of the opposite, so not US, not US, not US. So 1 minus 0.6 raised to the third power. 0.784. The first Japanese car is the 4th car selected. All right, so first off, we're going to 1, 2, 3, 4. This one is Japan, and these have to be not Japan. Well, what's the probability it came from Japan? 30%. So not Japan would be 1 minus that. So here's what I'm going to do. I'm going to go, well, 0.7 raised to the third power, press enter, and then I'm going to multiply that by the 0.3. So times 0.3, and I get 0.1029. All I did was multiply all those together. All right, so next one says ask for the expected value. So I'm going to go ahead and drop that, go to stat edit, clear some stuff out. And we have 2,000, 5,000, 10,000, and 20,000. Now, probability, this is always, probability is another word for frequency. I'm going to go ahead and put that in, enter those in there. And that's going to be 0.1, enter, 0.2, enter, 0.3, enter, 0.4, enter. Stat, calc, one variable statistics. Again, my frequency is my probability. And X bar is, that's my, well, the expected value equals my X bar, which is, in this case, 12,200. All right. And then we need the last problem. It says complete the expected value table, etc. Well, we're missing this value here. Well, remember, they all have to sum up to 1. So let's sum up what we have. So 0.25 0.25 plus 0.15 plus 0.1 plus 0.2. So that's 0.7, and then 1 minus the 0.7 gives me 0.3. So I'm going to go back and check myself just to make sure I have that right. Be really silly to make a dumb error on that. 0.25 plus 0.3 plus 0.15 plus 0.1 plus 0.2. 1 whole. Looks like I have it right. I'm going to go to stat edit so I can answer the rest of the question. I'm going to clear this out. And 0, enter, 1, enter, 2, enter, 3, enter, 4, enter, and 0.25, enter, 0.3, enter, 0.15, enter, 0.1, enter, 0.2, enter. All right, so I have those values in, stat calc, 1 bar stat. Remember, probability is the same as saying your frequency. So my frequency needs to be my probability, so that's an L2. And I get an X bar equal to 1.7. And this is a standard deviation, and this is a standard deviation symbol. And when I go back and look at my standard deviation, I end up getting 1.4525. And going to 4 decimal places. All right, so that takes care of that page. So we have this whole weather thing, and I'm not going to read it to you, but if one flight is selected at random from the airport, what's the probability the flight will have at least one of the two types of delay? So we have mechanical delays, and we also have ice delays. Well, this has a mechanical delay and an ice delay, which means it has two of them. This has an ice delay and no mechanical delay, which means it has one. This has a mechanical delay and ice delay, which means it has one. This one has neither. So this doesn't have an ice delay, so there's no delay on that one. So that has 0. What's the probability it has at least one? Okay, so I have several different ways I could work this. But that's the probability of 1. That's 2. So I'm interested, I could have 0, 1, or 2. Well, I'm interested in these values. Since it's an at least problem, I could do 1 minus 0.665. Because remember, we've always done was at least, whenever we had at least one, we just 1 minus. So I could do that, and there's nothing wrong with that. That'll give me the right answer. I can go 1 minus 0.665 because I subtracted out the 0 delays, and I get 0.335. That's one way to approach it. Another way to approach it is sit there and go, well, that's at least one, that's at least one, and that's at least one. So I could go 0.27 plus 0.03 plus 0.035. Well, let's try that out. 0.27 plus 0.03 plus 0.035. And I still get 0.335. There's still a third way to do it, but I would say that those are the two easiest ways. So I wanted you to use both of them. Now it says, what's the probability that it has exactly one? Oh, well, that means I'm not interested in this one, and I'm not interested in that. I'm interested in these two. So this is going to be 0.27 plus 0.035. So 0.27 plus 0.035 equals 0.305. So that's this answer. Now it says, given a flight has a mechanical delay, what's the probability it also had an ice delay? Well, remember, given is our intersection. So we have given, the intersection over given. And so we have ice. Well, the probability of an ice delay, as it turns out, is 0.30. Intersect. Oh, it says, I'm sorry, given it had a mechanical delay. So this would be mechanical delay, MC delay. So this is not, so mechanical delay is going to go on the bottom, so which is 0.065. Was probably, it also had an ice, so intersect ice. Well, ice is 0.03 because it's mechanical, and then the intersections where they cross, so 0.03. So 0.03 divided by 0.065 is 0.4615. All right. And then it says we need to create a table for this next one. So we have to read carefully. A laboratory test for the detection of a certain disease, positive result in 5% of the time for people who do not have the disease. Ooh, careful. Positive and do not have the disease. That's associated with two variables. The test gives a negative result 3% of the time for people who have the disease. This is also two variables. Large-scale studies show that the disease occurs in about 2% of the population. Ooh, That has nothing to do with the test. That just has to do with disease. So this is going to be my starting point, which is 0.02. And then 1 minus 0.02 is 0.98. Once I have that, I'm going to go ahead and write those values small, 0.02, 0.02. This is 0.98. This is 0.98. And once again, I like to keep my labels easy. The 2% who have the disease. All right, so this is disease. This is not diseased. Then the last thing is positive and negative. So let's go back and look at our other variables. Test positive, so I'm looking at the positive row, and 5% who do not have the disease. Who do not have the disease. All right, 5% not diseased, 0.05. That means this is 1 minus 0.05. Let's go ahead and multiply those out. So 0.98 times 0.05, 1.9. Then I need to do the same thing here. This is, so 0.98 times parenthesis 1 minus 0.05, or 95%. And this is 0.931. And if I did this correctly, this plus this needs to equal 0.98. So let's check it out. 0.931 plus 0.049. Hey, it equals 0.98. It looks like we're doing that right. Test also gives a negative result. So now I'm looking at negative, and 3% of the time for who have the disease. So 3%. And this is going to be 1 minus 0.03. So 0.02 times parenthesis 1 minus 0.03, close parenthesis, is 0.0194. And we have 0.02 times 0.03. That's 0.0. By the way, that means I have 3 zeros in front. Whatever the number is, it's 1 left for the number 0. So this is 0.1236. And you could have written that, just written 6e to the negative 4 plus 0.0194. Oh, that's 0.02, so that looks good. All right, so we're almost done here. This plus this needs to equal that. So 0.0194 plus 0.049, 0.0684. And now we also have 0.0006 plus 0.931. So this should be 0.9316 plus the 0.0684, and make sure it adds up to 1, and it does. All right, so there's our table. Hope that helps, and I will see you on the next one. Thank you.